Very good evening to everyone who has joined us today. Thank you so much for joining in. Today we'll be learning more about AWS Deep Racer and reinforcement learning. This session is also designed in a way to, keeping beginners in mind. So if you have no experience or you haven't learned about reinforcement learning or deep learning before, that's completely fine. We'll be going through the basics as well. And also we won't be diving too much in depth into everything as such because of course we have kept beginners in mind as well. So we will go through all the basic concepts and everything of reinforcement learning. So I'll just start my slideshow, just 1 second. It's loading, just 1 minute. Yeah, so I guess we are here now. So welcome once again. I'm really looking forward to this session. And okay, I guess it just got closed for some reason. Just give me 1 minute and I'll reshare the screen again. I'm so sorry.
Chisman, how, what's going on?
So it
Any
got
issues?
closed suddenly. No. I won't go to the slideshow. Yeah. So is my screen visible now? I won't go to
Yes,
the
yes,
complete slideshow format. I will just go
it's
through this.
visible. It's visible. Just yeah, it is visible. You can put it in presentation mode, or you want to keep it like this.
I'll try for the presentation mode once again. I guess that should
Okay.
work. Yeah, I guess it's working now.
Yes, it's working fine.
Okay. So we'll just see what we're going to learn today. So we'll start off with machine learning on AWS and why exactly are we learning this? One of the main reasons is that you don't have to install anything as such. All your machine learning and reinforcement learning models are deployed on the cloud, and in this case, it is AWS. So that is one of the main benefits of machine learning on AWS. And then the second point being working of the AWS Deep Racer. That is what we are going to see today, as in how reinforcement learning drives the Deep Racer, literally. We'll also see how reinforcement learning works in general, and also how it is being implemented in the AWS Deep Racer. At the end, I'll also have a walkthrough, AWS Deep Racer consoles walkthrough, and how to train your model on the AWS Deep Racer console. So we'll also be going through all of that today. Yeah, so this is the mission of AWS. I won't really spend too much time on this. So, I mean, the whole idea of even this session is to put machine learning at the hands of all the developers present in this session, or anyone who will be watching the recording later on as well. So yeah, so these are just some of the reasons why we have chosen AWS, and I won't spend too much time on this as well. Uh, AWS is the number one cloud in the industry and for machine learning as well. So that is why we are focusing on that today. So these are just some of the ML frameworks and infrastructure that is supported on AWS. Some of the frameworks being PyTorch, MXNet, TensorFlow. Now, these are not really needed for today's session, but they will be very helpful if you just want to have, or if you just want to train a model on your own, right? So that is the sole reason of why we are going through all of this today. Some of the ML services that are being supported by AWS are Amazon SageMaker, and this actually trains the deep racers model, right? And how it does, in the underlying nature of AWS, that is something that I will be going through at the end, the entire architecture of AWS Deep Racer and how the model is being trained on Amazon SageMaker. Then come the AI services like Amazon Recognition and Amazon Poly and Amazon Transcribe. These are AI as service, so you don't have to really code for them. You can just use them as a service. So I'll just go to the next slide. So this is something that is very important, right? So I have designed this session keeping beginners in mind particularly. So how can we get started if we have no idea about machine learning, or if we're new in the field of machine learning or reinforcement learning? So these are some of the educational devices that that are being provided by AWS. AWS Deep Lens being for computer vision and deep learning. AWS Deep Racer is to learn reinforcement learning better, and also how it is applied in autonomous vehicles. That is something that we'll be learning about today. And then the AWS Deep Composer to understand generative AI. So I'll just go to the next slide. Yeah. So here starts our main session, right? What exactly is AWS Deep Racer? To put it into perspective, it is basically um, a car, a model car, which is 1/18th the size of an actual Formula One car. And it is basically designed to test the reinforcement learning models physically on a track. So you can see your reinforcement learning model working physically in person, and how it is working, right? So that is essentially why AWS Deep Racer was made. What it does and how it does, we'll be going through all of that in the coming slides. Yeah, so we'll see some of the machine learning techniques. We've spoken about reinforcement learning, and how that, we know that AWS Deep Racer is powered by reinforcement learning. But let's just have a brief idea of what is AI, what are the different types of machine learning techniques, so that the beginners get a good idea of what exactly we'll be doing in today's session. So let's start off with supervised learning. Uh, in these circular diagrams, you can see that there's AI, and within that there's ML, and then within machine learning, we have had supervised, unsupervised, and reinforcement learning, right? Supervised learning basically deals with ML models that are labeled. That can be, I guess, linear regression or something like that. Unsupervised learning, in that case, the ML models are not labeled, right? So, most of generative AI is unsupervised learning, although GANs are essentially semi-supervised. But unsupervised basically means that there is no data provided, and then the model learns from the underlying patterns of the data provided. So that, the data is not labeled. Sorry, I guess I said there's no data provided. So the data is provided, but it is not labeled. So it's just raw data given. It's not labeled, and the model learns on its own, seeing the underlying patterns. Reinforcement learning is something that is very different, right? Because here, in the supervised and unsupervised learning, you're giving the data beforehand, uh, be it labeled or unlabeled. But in terms of reinforcement learning, the agent gathers the data when it's in the environment, right? What is an agent and what is the environment that I'm talking about? So let's think about the deep racer car. The deep racer car is on the track, right? So the track is the environment in which the agent, that is the AWS deep racer, is present. So eventually what happens is, when you place the car on the track and when it begins to run, at first it goes off the track. It goes off the track many a times. So how it learns is basically, you reward it for being on the track, let's say, right? I'm just putting it into simple perspectives. So just to give an example, a reinforcement learning model can be something like training your dog. So when your dog does something good, or if it listens to you, you reward it. by giving it a treat. And if it does something bad, you obviously don't punish it, but you don't give a reward, you don't give a treat. So eventually your pet will learn, what actions will get it rewards, right? In the same way, the reinforcement learning model's agent, right? So when it's in the environment, after probably 1,000 iterations or something, after 1,000 crashes, it will learn that, if I'm on the track, I'm getting higher reward points. And that is essentially how it will, at probably 2,000th iteration, it will complete a full track, a full circle on the track without moving off the track. So this is essentially how a reinforcement learning model works. So yeah, like we discussed, the reinforcement learning puts the auto in autonomous car, that is the deep racer in this case. They learn by a reward function or like punishment, right? So if it is on the track, or if it's at the center of the track, it will get more rewards, and if it goes off the track, it will get lesser rewards. So eventually the car will figure out, the model will figure out that it is getting more points by being at the center of the track. So it'll try to be more and more at the center later on. This is what this is what the console looks like. I will be giving a walkthrough later on, so don't worry about that part. It's not a very difficult aspect. So once we learn what exactly is reinforcement learning, I mean putting it on the console shouldn't be much of a problem. So yeah, we've already gone through what exactly is reinforcement learning and the rewards and all of that. But here I'll just go through a general description, right? It is basically a machine learning technique in which an agent explores the environment and it learns from its own actions, right? So exploring and exploitation, these are the two terminologies that are very important in any reinforcement learning model, right? So for example, right, you can see here the agent, it is performing an action in the environment, which is the track, and then it gets a reward based on the action that it takes. What is a state, you may ask? A state is a snapshot of the environment that it is present in. So suppose, let's say I've placed the car on the track, right? So at any given point of time, the image that the car will take through its front camera, that is a snapshot of the environment, right? Because it's on the track. So that is the state of the car at that point in time, right? So we know what a state is, we know what a reward is now. So based on these rewards that it gets, it will further on start improving its actions. Now, how does it do it, right? What's the process? Is there a particular method to go about it, or does it just go randomly, right? So how does it exactly go about the track and all of that? The methodology is exploration and exploitation. So first, the car explores its environment. It goes off the track many a times. It goes straight. It goes, haywire at times, and then it starts exploiting the data that it has. Now it knows that if I go off the track, I'm not getting more rewards. But if I'm staying on the track, if I'm at the center of the track, I'm getting more and more rewards. So in that way, it will start exploiting the data that it has. And that is essentially how it will start, avoiding bad outcomes. So this is exactly what the deep racer does. And yeah, I'll just go to the next slide. So these are some of the reinforcement learning terms that we must know for this particular session, right? The agent, environment, state, action, reward, and episode. So we know what an agent is, we know what an environment is, we know what a state is, we also know what an action is, and we know what a reward is. We just have to know what an episode is. So an episode is basically, the car starts at one point of time. Like let's say it starts from the starting point and it crashes at some particular point of time. So the start point to the end point, that can be crash or completing the race. That uh, that particular time, this whole experience is called an episode, right? So the start and end is called an episode basically. Uh, I'll just walk you through the entire thing once again, just because all of these terminologies are mentioned at one place, so it will be much more easier to grasp. So we have an agent, which is the AWS Deep Racer car. It is in an environment which is a track, and the state, of course, I guess it's better shown in this particular diagram, like a square and on the track. So it is a snapshot of the track at any given point of time, and that is called the state uh, of the of the environment, the state of the agent. And actions, the actions can be, going straight or going left or going right. So those are the actions taken by the agent, and the reward is essentially a feedback, you can say, that the agent gets for every action that it takes. So if it's on the track, if it's at the center of the track, and if it's not hit any obstacle or something, it gets more rewards. And if it goes off the track, or if it hits any obstacle, it gets lesser rewards. And an episode, of course, we learned now, starting point to end point, that complete journey is called an episode. So I'll just go to the next slide. Yeah. So I guess we have discussed this quite a lot of times, at least as of now. The agent in our case is the deep racer car. The agent embodies the RL model that controls the vehicle by taking inputs and deciding which action to take. So yeah, I mean, this is something that is very well put into words, but I just tried to explain it in a much more simpler way. If you understand that, I mean, okay, you have created an RL model on the console, but this kind of embodies the RL model. You can see the RL model work in a physical state and using the deep racer car. So your agent in a way is an embodiment of your RL model. The environment in our case is the track, right? It describes, yeah, this is a very important point. The environment describes what all actions it can take and what state it can be in. So for example, in our case, the environment is this particular track. Okay, let's say this particular track is an environment. Now let's say there's another track over here that is not at all associated with our uh, model and with our training purposes. We are supposed to train it on this track. Now what can happen is, probably if there's no border in between, you can say that okay, the car can go from here, it can probably start going on some other track, right? But our environment is this. So even if it's doing really great on some other track, uh, our whole objective should be for it to train on this track, because this is the environment. So this describes where the agent can go, right? That was just the other track was just an example in a physical state. Like if I'm racing to my deep racer car on a physical track, and the track, there can be another track side by side. So but if you're doing it virtually, if you're simulating the AWS deep racer car, then that won't happen, obviously. So the exploration and exploitation, we have already discussed. It tends to explore more initially to exploit that data. So if it explores more, it can collect better data, and it can know better as to what actions are giving it more rewards. So I'll just move to
Now,
the next slide.
Architman, a quick question
Yes.
here. So you might have already discussed this. So while this is a
Yes.
deep racer in AWS environment, it can be
Yes.
used for simulating other real-world RL applications, right? So it doesn't mean that this solution only works for training a racing car. This is a
Yeah.
simulator for training real-life RL applications, whether they be in financial services or supply chain forecasting, right? Or self-driving vehicles, or resource optimization, asset optimization. So any RL application can be modeled and simulated with AWS Deep Racer. Am I right?
Yes, sir, but actually, the deep racer is entirely constructed in a way for autonomous vehicles only. So, the topics that we have discussed till now are applicable for all reinforcement learning models. But when we walk through the console and all of that, these terminologies will help. So that was exactly why I was, mainly focusing on deep racer.
No, no, this is great. But what I was asking was Deep Racer is not only for training racing agents, It's also for creating simulator for other real world business application. Am I right?
Uh, Not entirely, sir, because I mean, underlying Deep Racer, there is Amazon SageMaker and the S3 buckets, so all of that. So we can train our RL models on Amazon SageMaker. The Deep Racer console, there's a different Deep Racer console entirely only for this purpose. So, I mean, it would be much more easier for the attendees to learn why the Deep Racer console I felt. So I was just explaining everything on from that perspective.
I think your explanation is great. I'm not commenting on that. I was just saying that Deep Racer overall allows me to train other RL agents, but that's okay. If right now this clarity is not there, so you can continue, please.
Okay, sir. Thank you. Yeah, so we have discussed about the state. The state is basically a snapshot of the environment, and I mean, in which the agent is present, right? So, as you can see, this particular graphic that explains. So, suppose our deep racer car is on the track. The front camera will capture this image. It will see this through the camera, right? And at any given point of time, it will probably just see this. And this is the state of the environment that the agent is in. So that is exactly what the state stands for. Yeah. So actions in our case can be, steering or throttle, increasing or decreasing the speed, moving left or right, moving straight, stopping, or just starting. These are some of the actions that the deep racer model or the agent can take essentially. In our case, these are the actions. So here comes the actual, understanding of rewards. So like we discussed, a reward is essentially a feedback given to the agent based on its actions. The feedback can be divided into two parts, yeah, reward and punishment. I've already mentioned this, so I won't really reiterate over it. What you only have to understand is that rewards are, I mean, it's a way of uh, making the agent know as to why exactly a particular action is a good action or why it should continue taking that particular action. Like I gave an example of a pet. If it does something good, you give it a treat. In our case, we give the model a reward. So that's essentially the difference. That's it. The other understanding of the pet example and the rewards is entirely the same. So let's just go through this code given on the left hand side. If you're viewing this from your mobile, it might not probably be uh, visible entirely, but this code will also be visible when we go through a walkthrough in our AWS Deep Racer console. So no worries about that. I'll just go through this code briefly to explain. Uh, Here you can see that there's a reward function and it takes parameters. In our case, we can give different input parameters, right? So here we have given track width and distance from center. Here, if you can see that we have taken three markers: marker one, marker two, marker three. Marker one, um, and we have had point one into track width is equal to marker one, 0.25 into track width is equal to marker two, and 0.5 into track width is equal to marker three. Now I know this you won't really understand this in if I just put it out as a code. I will show it to you as a graphic. I'll just move to the next slide. Yeah. So this is what we did essentially, right? So this is our deep racer car on the console, and if it's at the center of the track, it'll get 0.1. I mean plus 1 point. So right. So this is the distance from the center, guys. This is the center line. Distance from the center is calculated like this, and the track width is this entirely. So the entire width of the track, end to end, is called the track width, and distance from the center is calculated from here. So let's go back to our code. And marker 1 stands for 0.1 into track width, marker 2 is 0.25, and zero point 0.5 into track width is marker 3. So you know that the markers are going further away as we go down: marker 1, marker 2, marker 3. For the distance from the center, if you see the code here, if the distance from the center is less than marker 1, give a reward of 1. Else, else if the reward, if the distance from the center is less than marker 2, that is less than 0.25 into track width, give the reward as 0.5. Otherwise, the reward is 0.1. And if it goes off the track completely or crashes, then it is 10 power minus 3. So if you can notice a pattern, here the distance is going on increasing in terms of markers, initials like marker 1, marker 2, and marker 3. And here the reward points are getting decreased 1, 0.5, and 0.1. So that is what we have depicted here. The more the car goes away from the center, it keeps getting lesser points, and if it's uh, towards the center, it gets more points. So that, I mean, that is essentially what it is, and we will also see how it will learn eventually to traverse through the track. So let's just divide the track into grids, right? Into grids, and we have marked the points for each of the grid sets. So and let's just say if the car moves one step at the center, it gets 2 points. If it goes left, it gets 0.2, and if it crashes, you can see X marked over here for the borders, so it gets 0 points there. So I'll just go to the next slide. So like we have already discussed, an episode starts from, right? So here it has crashed, it has started, and it has crashed over here. So this marks one episode. Now, if you can see, the car was initially at 0 points. This stands for 2 points, this stands for 0.2. So in this case, the car has got 2.2 points, right? And yeah, so we have to iterate a lot of times, obviously, because learning is an iterative process, like we have mentioned here. And it's only through multiple iterations that you will get a well-trained model. It's only then will the agent understand really as to which path is the best to traverse, or which actions are the best to take, and which are the most rewarding ones. So if you can see here, the car has gained more points than the earlier episode. So here also it's one episode, here also it's another episode, because the car is starting from the starting point and it's crashed, so it's an end. But here you can see the total points are 2 plus zero point 0.2 plus 2, oh, sorry, yeah, plus 2, and again zero point 0.2. So here obviously the rewards are more. It is, I guess, 2 plus zero point 0.4, it's 2.4, and here it is 2.2. So in this case, the rewards are 2.4. So the next time the car knows that, okay, I don't have to just stop there, because there in that case I was getting just 2.2. I will probably take a point 2, and I'll take a, diversion from there and go somewhere else. I'll traverse some other part of the track. So we have already mentioned about exploration and exploitation. Don't worry too much about this graph. All you have to see is, I mean, because this is just for comparison with another graph that I will be showing in the next slide. So this is in the exploration phase. This is the total reward that it has got, right? So, and as compared to the episodes. So if you see the diagram, the car has completed the lap. It has reached the end, and it has obviously got more reward points than the first episode. So this, I mean, this has obviously been attained after many such episodes and after many such iterations of training. So that is how the car has learned that, okay, I don't, if I go for this point 2, I don't have to just keep going in that direction, because I will just get point 2, not more than that. So it goes straight, then goes towards 2, something like that. Now, if you see, okay, sorry. Yeah, so now if you see in the exploitation phase, the reward has gone, I mean, this graph has gone up. The exploration phase, the total reward was here. And now the card has collected some amount of data and it wants to exploit that data. So if you see, the total reward has gone up as compared to the episodes on this graph. And also, I guess the points are completely high. It has just gone in a straight line. It knows which direction to traverse now. Which actions will get it maximum number of reward points. So it knows that. And based on that, you can also see the rewards have gone up. So it is a good indicator that your model has done well, your model has been trained well, and it has performed well. So yeah, these are some of the parameters of the reward function. I'll go back to the code. So here, what are the parameters we have used? Here we have used track width, we have used distance from the center, right? These are the only two parameters that we have used. But you can also use parameters like speed, steering angle, right? Why steering angle? Suppose the car is steering a lot towards left. You don't want it to steer that much. Reduce the steering angle, right? So it will automatically, be uh, trained in that specific parameter. So I'll just go back to show all the parameters. So here is the track width that we had used. Sorry, yeah, here. This is the heading of the car, right? You can also have, the how much the wheels are turning with respect to the car. You can also have that. So that is the steering angle. Distance from the center is the parameter that we had used here with the track width, right? And then we have the heading of the car. We can also have position of the car. If you know, so okay, let's have the track over here. You have the x-axis and y-axis mentioned in the coordinate plane. So suppose this point, right? You know that this point is definitely going. It's going off the track. If you have coordinates in any particular, area of this area or this area, if you get coordinates from this area or this area, you know that it has gone off the track. So you can mention that as a parameter also with the x coordinate and y coordinate. So yeah, so this is the underlying architecture of Deep Racer. It is a completely built console that is given, so you can understand reinforcement learning better. You can train your Deep Racer models, compete in virtual races, AWS Summit races, or even physical races if you're attending an AWS Summit. I'll just explain how the Deep Racer works under the hood. So this is the AWS Deep Racer that you'll be, you clicked on create model, right? So basically the RL models are stored in Amazon S3. The simulation is done using AWS RoboMaker, and the models are trained using Amazon SageMaker. The logs are, stored using CloudWatch, and the video of the training, you can also see that. You can also see your, Deep Racer training in the virtual circuit environment using Amazon Kinesis video streams. And it is finally deployed on the edge. If you're using a physical AWS Deep Racer, an actual RC model, then that is deployed on the edge using Intel's OpenVINO. So this is just something on the basic that you should know. Even if you don't understand the entire working of it, this is just something that I felt everyone can know. So yeah,
So you
it's
are
lab
saying
time.
it is using Intel OpenVINO architecture in backend.
Yes, sir. The actual Deep Racer vehicle, if we have to buy it, like for the simulation, it doesn't use, but for edge deployment, it uses OpenVINO.
Okay, for the chip. Okay, edge computing.
Yes.
And I was reading in the internet, it uses a specific RL algorithm which is called as proximal policy optimization, PPO.
Yes, sir. Yes, sir. Yes, sir.
It uses PPO, which is an actor critic model in reinforcement learning.
Yes, sir.
So yeah, that's one of the advanced algo we cover in our RL course, in fact. So Shubha taught details of that. Okay, this is good. Please continue.
Yes, so we'll just a second. Yeah. So we'll go to the next slide. Yeah, it's our lab time now. I'll just show you how it. Yeah, so basically, I just wanted to put it across that if you have to train your own model, it will take around 60 minutes or so to get a good, well-trained model and well-evaluated one. So it'll take 60 minutes. Now we obviously don't have that much of time because I can't train a model for 60 more minutes and just wait over here. So I've already, trained a model and evaluated it. And so I'll just show how that, but I'll still show how to make your own model. We'll not deploy one as of now. We'll just go through the entire process of making a model. So just give me 1 second. I'll stop sharing my screen and share it again.
So friends, this is Vivek from CellStrat. We have a very extensive course on deep reinforcement learning, which we offer in CellStrat, taught by our RL team lead, Shubha Manikarnike. And it is a very big course and probably the the best course you can find in this space, at least coming from India. And so that is algorithmic course, but what Archisman is able to show here is an AWS Deep Racer simulator, which is provided by AWS, which internally uses one of those RL algorithms called Proximal Policy Optimization, or PPO, which uses an actor critic architecture of RL. So this session really brings us closer to actually implementing RL through AWS. So we appreciate Archisman's work here. Yeah, please continue.
Yes, is my screen visible?
Yes, yes.
I'm on the AWS console. Okay, that's great.
Yes.
Thank you, sir. So this is exactly what the AWS Deep Racer console looks like, right? So you can see how it works and all of that we have just discussed. You can also submit your model to the Deep Racer League after you've trained it. So we'll just go to your garage first. In this case, I'll just go through the entire process. If you want to make your own, if you want to build your own Deep Racer model, even virtually. So I'll create and build a new vehicle, right? So we can see these specifications over here. We can configure our.
Are there any cloud charges if I start doing this in my personal AWS account?
No, sir. I guess a few credits are. I mean, it comes under the free tier completely for a few models. I guess we can't have more than 3 models or something for 60 minutes training. So I guess that will come under free tier entirely.
Got it. Got it.
So yeah, so I mean, this is a camera that we'll use for now because we are just going through a time trial race. Time trial, as in we are just racing against time, just improving our speed of completing the race. There's also something called head-to-head race. So in that case, you train your reinforcement learning model to avoid obstacles on its way. But and that would probably require something like stereo camera because that uses 2 cameras, like you can see here, and also a lidar sensor to detect other deep racer cars if they are also competing with you on the track. For now, we won't use all of that. We will use this 120-degree camera, right? So let's go build a vehicle. So here you can see something like, yeah, so this is the action space. Like we discussed, so this is a max left that the car can go, and this is the max right that it can take. We can also adjust the steering angle 31 now it's 29 degrees, 28 degrees, 30 degrees, and then the steering angle granularity also. Maximum speed can be increased or decreased, and the speed granularity as well. I won't really go too much in depth about that, but what you'll have to see here is depending on the speed granularity, these steering angles and all of that will change. So I'll just change this to 3. So if you can see, the speed has changed here, right? The speed is being changing with respect to the steering angle. If I keep 1, the speed is the same. Steering angles are minus 30 degrees, minus 15, 0, 15, and 30. So we'll keep it to 2 for now. We'll stick to default. I click on next, and then here we have our model. We'll just have to name it, right? And our model will be created. If I click done, it'll be done. So I'm not showing that now because again that will probably take some while to load and all of that. I'll go to new model. Yeah. So this is the new model that I've already made, but I won't really show that as of now. I'll just create a new model here. So you can see this button. I click on create model, and then yeah. So yeah, here is the just a brief description of what we have learned till now. After training, you'll be able to evaluate the model's performance and all of that. So this is something that we have already gone through before, and we will also see that in the coming steps. So I just give it a name as model 1, right? You can, this training job description is optional. If you want to, you can add, or you can also, I mean, skip that. Okay, I guess this isn't refreshed. Also, it's very important to note that depressor is only available in the North Virginia region. It is not available in any other region. I'll just go through it again. Yeah, so we're here. This is something that you will see when you log into your AWS account. We'll click on AWS Deep. You can also click and find services. You can find the AWS Depressor there. And yeah. So yeah, this was something that I was talking about. You can only find it in the North Virginia region. So I'll just pause it for now. My models. Yeah. We are here, create model.
So we are saying we cannot get this depressor in any other AWS region.
No, sir. It's only available in North Virginia.
Since Hellstat, we are using US East Zone for AWS. So US East Zone will not have this, huh?
I guess North Virginia will come in East only. Yeah, US East one.
Okay, okay.
Yeah, so the training job is optional. Here you get to choose from a variety of tracks. So this can, you have different types of tracks. I am choosing Reinvent 2018 track to train my depressor model. So yeah, I click on next now. Then we have chosen time trial. Like I also said, there is head-to-head racing with other depressor vehicles and object avoidance. Now here, if you've created a model in the garage that we saw, you will get options over here, probably with the other models or the other depressor cars that you have customized there. Here we haven't, so there's just one. I clicked on it. Yeah, so here this part is, I guess, the most important one. Reward function, right? So we have already gone through what is the reward function and all of that. So you can see the parameters that we've chosen here are track width and distance from center. You can probably, I can give it 0.3 as, you know, 0.3 as this thing, the distance probably. And here I can give, here I can reward it probably as 0.9 per se. Here I can decrease the rewards to 0.2. Sorry. Yeah. So yeah, I mean, it's still essentially decreasing, right? Now, if I increase the rewards, it will start probably going in the other way. It'll just start moving off the track mode. So we saw the working of this code there in the presentation. You can also find, you can write your own reward function completely. So this is just a code editor. You have to write your own reward function. This is, I mean, already made available to you. So here you can find different types of code function reward function examples. There's also separate, completely different code made available to stay inside the two borders. I mean, the two borders of the track. So here, the one of the parameters is all wheels on track. This is also a parameter that even if one wheel of track, so why this is helpful, right? Probably at times what can happen is, I'll just show it via this here. I hope you can see the presentation now. So the car is here, I guess. Yeah. So if you can see this, the car is here, right? So even if one wheel of the one wheel of the car goes out, then it will not be rewarded um, for that particular action. So that is one of the parameters that we have kept here, that all the wheels should be on the track, then distance from the center and track width. So these are the parameters that we've chosen for this, for it to stay inside two borders. Preventing zigzag, the parameters would be steering. I said steering angle also can be used, so you can use steering to prevent it from going zigzag. right? Head to head and object avoidance. So all of these parameters can be used. And you can also validate, right? Validate is something like um, um, testing your code against test cases. So that is something that the validate does. Reset will clear the code completely. We'll go to the next set of doing this. So this is something that Sir mentioned. It uses PPO. So there's no other option. If you see, it's already ticked over here. That's the only algorithm that it works on. Now let's see what the hyperparameters are. So what we have looked till now, I mean, what we have seen till now is basically just the parameters, and we have defined them in the code. Hyperparameters will be defined before your code starts running. So let's see what all of these are. First comes the gradient descent batch size. This basically refers to the number of recent vehicle experiences that are sampled at random, which keeps updating the underlying neural network. So suppose you have 5,000 experiences as of now, and you choose to just give 10 batches of your completely 5,000 experiences. You choose to give 10 batches of such experiences. I mean, they are divided into batches then. And so these in terms of I mean, which in gradient descent, the batch size, how many, so this is the size of the batch that keeps updating the underlying neural network. So what can be the size of the batch? So I'll just keep it 128 for now to keep it neutral, right? I don't want it to make, I mean, I don't want it to update faster or slower. If you have a larger batch size, the training can be slower. Number of epochs. Number of epochs basically means, you have these many, I mean, this is your batch size, you have multiple batches, and you train all the batches at once, right? So suppose, let's say there's one complete training of all batches. That is called one epoch. So how many such times do you want to repeat that process? That is something that is called number of epochs. So I'll keep it to 5 for now. I'll just keep it to 5. Learning rate. Learning rate is something that basically, how big the updates are, right? So you know that the neural network has weights. How rapidly, or how big are the updates in the weights of the neural network? So 0.003 is, I guess, fine. That should be a fine. Entropy. So we spoke about exploration. In what exactly happens in exploration? The agent explores its environment. It collects a lot of data. Now, how random do you want that exploration to be, or how random do you want the car to move? That is something that is described by the entropy. Entropy essentially means randomness, right? So that is basically that. Discount factor. So suppose I just give 0.9 discount factor. This is just for simplifying the explanation. Discount factor is something that probably what future rewards can I use to take the next step. So suppose the car has already explored. It has explored the track. It has explored its surroundings. It has explored the environment. So for the next step, probably it has also there's also a possibility that it has already traversed through the future path that it will be traversing for the coming round. It has already gone through that path for the previous round. So for how many such future rewards should it consider the next step? Like suppose I have got say 10 rewards. For the next 10 steps, I might have got some rewards. So I can use those rewards to understand which next step, which next action should I take. So if I'm mentioning point 0.9, that means it's for the next 10 steps that I'm keeping in mind. That the next step that I'll take, I'll see the future 10 rewards that I had got, right, on the same path. And depending on that, I'll take the next action. So if I'm mentioning 0.999, that means for the future 1,000 rewards, depending on that, I will take the next action. So in this case, we are using the Hoover loss type. That is something that I would not really like to go deep into for this session. Yeah, so we have now number of experience episodes between each policy updating iteration. So how many experience episodes do you want to have between each policy updating iteration? Policy is basically something that your reward function describes. So we want to have 20 such experience episodes. Episodes we have already gone through, the starting and end, the entire journey. is called one episode. Stop condition. This is very important because, like, okay, regarding the cloud, you also have to pay for the services, right? So if you're creating this model, it's obviously it'll come under free tier only. But if you want to create many such models, then you'll have to pay for it. Now, when you're paying for it, so suppose I have kept this as maximum time 60 minutes. It should stop the training automatically after 60 minutes. It shouldn't go longer than that. So even if I'm not like if I'm not looking at the console, I can go away and I can come back after 60 minutes and it'll automatically stop the training for me. I don't have to manually stop the training in that case. So this is very important in that case. And yeah, this is just automatically submit to the Deep Racer League and you create the model here. So this is essentially how a model will be created. I will show you how it looks like in the console once the model is created. So here you can see, I'll just highlight this. Model training is charged at a flat fee of $3.5 per hour. Model storage is 0.023 per gigabyte per month. The AWS free tier, the AWS Deep Racer free tier gives new users 10 free hours towards training or evaluation. So you have first 10 free hours. So that is completely fine. So yeah, we have created a model as of now. We have gone through different reward functions and all of that. So I'll just head back to Deep Racer. I have gone to my models. Yeah. So I have new model over here. So you can see evaluation has been successfully completed, auto submitted to the virtual race. So yeah, training info, right? Training. I'll just click on this. So this is something that you'll see. Now I've already clicked a snapshot of when it was training. So if you can see here that you'll also see the video of your training, by the way, how your car is performing on the virtual track. But this is only visible only when the training is going on. So because our model is already trained, you can't view it now. You can see the reward graph, obviously. So if you can see, the maximum reward was at this iteration, but I guess we have done it for about a little more than 250 iterations. So yeah, we should have stopped at 200th iteration probably, and here the reward was maximum. You can see it's written best model. The blue and green graphs basically just represent percentage of completion of training and evaluation. So don't keep that in mind. I'll just remove these. Sorry, reward. Just a second. Sorry. Yeah, the green thing is a reward. Sorry. Average reward is the green graph. And yeah, here you can see. So probably the best model was over here considering the other parameters as well then. So here the reward was at peak, but then it went down. So if you can see, this is something like what we saw in the presentation too. So you will see this graph of reward and average percentage completion of training and evaluation here. So I'll just move on to download. Yeah, you can download your log. So if you knew, we also saw CloudWatch, right? Amazon CloudWatch. I guess it was here. Yeah. So if you can see the CloudWatch over here, Amazon CloudWatch, that stores the logs. Yeah, here. So you can also download the logs. You can view your evaluation, how it is doing on the track, right? Trials completed, and the status, has it gone off track or lap has been completed and all of that. And then in the end, you can see your obviously reward function action space and all the details that you already knew that you yourself entered in the hyperparameters. I'll just show the snapshot of what it looks like while it's training. Yeah, just give me 1 second. I'll stop sharing the screen. I'll reshare it again.
So Archisman, the question is, do we need to know
Yeah.
RL to use this?
Not at all.
Do we
Not
need
at
to
all, sir.
know?
I mean,
Because some
we
of the
just have to know the
aspects,
basic
I mean,
understanding.
yes, that's what I was thinking. Some basic idea is needed. Otherwise, for a brand new person, the aspects of state, reward, action paradigm will be very new, and they will not be able to understand why we are doing what we are doing. So I think a basic
Yes,
RL
yes,
or the
completely.
Markov decision process and the discount factor, some basic knowledge of RL is needed to be effectively use this tool actually.
Yes, sir, yes, sir. Just the basic
My
idea,
next,
like exactly what
yeah,
exactly is doing, I guess that would also work.
the Markov decision process is has to be known. The reward equation with discounted future rewards. My other question is, let's say I am not interested in racing, so this is not
Yes, sir.
relevant for me.
So this is relevant in learning the RL technique in
Okay,
general. So like we
okay,
saw, the entire process of the hyperparameters that we use or the parameters that we use, although it was framed in such a way that the application would be the deep racer car, but the points or or the reward functions that we use, the idea will be the same for any application. The basic underlying idea, it will be the same.
so it is
It's just that the
gamification of
console,
RL skilling. So this is gamifying
yes,
how
sir.
to skill in RL. Okay, fine.
Yes, sir.
I think Archisman, we should add this as a module in our RL course. I'm thinking, right? So we should add
Yes, sir,
this in
sure.
our RL course. Okay,
Yes, I
kindly go
guess
ahead.
that would be great. Yeah, so I guess I mean, if we are done with the session, I just wanted to show this snapshot of what it will look like. I'll just move to the slideshow. Yeah. So as you can see here, we just saw what the reward graph was. Here you can see it's still undergoing training, right? So you can see the video stream over here, as in how exactly your car is performing on the virtual circuit. And sorry. And the reward graph, as you can see, the green was the reward. So it was doing pretty well that time. But the iteration was only about 150 or something. But we have done it for about 257 iterations or something like that. So if you see in the long run, that is the reason why we need so many iterations. Um, like that is only if you have more number of. I mean, of course, you don't have to have too many iterations. Then in that case, your model will learn completely different things which are not needed. But many, as in, it's always good to have about 250 to 300 iterations for such applications, because then in that case you will know how exactly your model is performing in various states as in the snapshot of the environment essentially, and what actions is it able to take. Because like if I just have it for one episode for one iteration, the car might go straight and it will get 2 points or something. So in that case the reward functions graph might go up, right? But if I have it for about 10 iterations and for probably 2 3 such episodes, it might go left and right. So in that case the reward graph might come down. So that is why it is very important to keep iterating. I mean, your training, it is very important to have episodes, more episodes, and many iterations. So I just wanted to show this snapshot because then you will understand better of how the exact output will look like. And yeah, I guess we are done with that then. I
Yeah,
hope you
if
guys enjoy the
possible,
session.
can you show
Thank you,
it?
sir. Yes, sir.
Can you show the simulation happening, the car moving forward after being trained? Is
So
that possible?
actually, it only happens only like while training. So I'll show it here. Um, So this window that we see, it is like in the console, it says the simulation video. I mean, we can't see the stream available now, but the video is only available when the training is going on. So here I managed to capture the snapshot when the model was training. I just took a screenshot. But after the model has been trained and deployed, then the video is not available.
Okay,
Otherwise,
got
we'll
it.
have to wait for like 60 minutes or something for a new model to train. And
Got it. Got it. So, so you said this is useful for learning RL or understanding RL through a simulated environment, and if somebody is interested in gamification, they can participate in the Deep Racer Global League. So Amazon is actually running actual real global leagues. So they've created a gaming platform around it. Uh, but so far we haven't seen that this can be used as a simulator for other business applications. such as in reinforce, supply chain or a stock portfolio management or asset allocation. So that's not something we have seen being a depressor being used. Uh, so we have this product idea in our product team where our RL team lead Shubha is trying to envision a RL product stack on our AWS cloud. So the question would be, should we build a depressor or should we build our RL playground product idea from scratch? Uh, any comments on that, Archisman? You are part of the product team, so you understand what I'm talking about.
Yes, sir. Uh, so I guess Deep Racer would only help in a better fashion to understanding the underlying concepts of reinforcement learning, because the participants or the attendees will see their model actually working and probably getting the reward points. So like when it's training, they can actually see the car crashing left and right and in the exploration phase. So after a certain point of time, it starts getting the rewards and it starts to understand, okay, I have to be on the track in that case, and so it will probably start exploiting the knowledge that it has. So I guess for that purpose it might help, but I don't think AWS Deep Racer would help like as a in any other application as such. So I guess it would definitely help a lot in learning, but apart from that, I guess the use case is very limited.
Is this competing with OpenAI GIM and Unity reinforcement learning models? So Unity, which makes AR/VR software, they also have a machine learning model and they have gaming simulation for RL, and so does OpenAI GIM. So does this compete directly with OpenAI GIM or it's a different kind of product? In
I
OpenAI
guess
GIM,
this
I
would.
have CartPole and other kind of simulators for RL, right?
Oh, okay. I guess this is a completely different product in that case, because the sole objective of this particular product would only be to it's just directed in one line of autonomous car racing. So I don't think it
Ah,
has much flexibility in that space.
okay. I did see a demo of this in action at Amazon AI Conclave in Bengaluru last year and the year before that. So they had a racing car track set up and they were showing the real car moving around. So you said it's using Intel OpenRhino for edge computing.
Yes, sir.
So those are the chips which are running in the car, the physical racing car, which you see in that real circuit. And so that is running this depressor model. So they have compressed the AWS depressor model into an OpenRhino stack, Intel OpenRhino stack to be installed on the chip set on the actual racing car. So any other questions, audience? A very interesting session by Archisman here, and Archisman is a third year BTech student from BMS College of Engineering. And so he does some remarkable stuff in these sessions, even though he's just a BTech student still. Any other questions, audience? So Archisman is also the appointed AWS ambassador at BMS College of Engineering. So Amazon has asked him to evangelize AWS on campus in that college. Okay, let's see any questions are coming here or not. Very nice presentation. So yes, indeed, I agree with that. Any other comments
Thank
or
you.
questions, audience? Okay, so thank you all for joining. Thanks a lot, Archisman. Really well done. Great session. Enjoyed it thoroughly. And audience, thanks for joining. And I'm sure you enjoyed it as well. Thank you. We'll see you in our future sessions. Have a good night, folks, or good day based on your time zone around the world. I'll see you later then.
Thank you so much, sir. Thank you so much, everyone.
Thanks, Archisman.